Now, whenever you do a grouping problem, you cannot go to the next step unless these two are the same.
Right.
That kind of kicks ass. If that's not the same as that, you've made a mistake. Right? Or else it's just not factorable. Most of the time, it means you have made a mistake. Maybe you didn't take enough out. Maybe you didn't take a negative out. Maybe the signs are off. Right? So you say, okay, I set this guy up, and I'm pretty sure about this guy, so I know I want this to show up there. It's a nice internal check. The problem's telling you, oh, by the way, this is what you should see. You're like, thanks, problem. You don't do that for me all the time. So what comes out of this?
2
5
squared
minus 1.
Now, just to address a concern you guys might have, because I hear people saying the other way around, is this any different?
No, it's the same thing.
It's the same stupid thing, right? 5 times 4 is the same as 4 times 5. I can commute multiplication problems, right? I can move them around. Cool.
See, if the sign not plus 7y, it is minus 7y.
All right, we'll do one like that. So you guys actually, let me see what you guys think about it here. You guys try this one on your own, which means I'm really going to make it work right. That would be nice, wouldn't it?
Exactly.
Oh yeah, let's do that. Keep it safe. There we go. Perfect.
Same mistake, huh?
Yeah. True.
You can't take something out of all of them.
You gotta be careful now.
You can
So
take
this is what I
X.
mean. If you put parentheses in, you have to remember, if you put parentheses right here, you're taking a negative out.
Yeah, change the sign on the A.
So don't put parentheses in there. What do you have to take out of here?
X.
X.
Yeah,
A
minus X. Okay.
Now over here, what do I want the A term to be? I want it to be positive, right? And I want the X term to be negative. And right now, that's exactly how they are,
Right.
isn't it?
Yeah.
The A piece is positive, and the X piece is negative.
You don't have to change a
And
thing.
if you make a mistake, if you take a negative B out, maybe some of you guys took a negative B out, this would become positive and that would become negative, and that's just trying to tell you, hey, you shouldn't take that negative out. Because these are not the same, are they?
You're going to take the X out.
So if I took out a positive B, I'd be left over with
Negative dx plus a.
negative X
Negative X, I'm sorry.
plus A, right? And are these the same?
No.
Yes?
Yes. This has got a positive A,
Okay,
negative
that's
X, it's got a positive A, negative X. It's just turned around.
Why are you taking a positive B as opposed to a negative B?
Because what I just did. What happens when you take a negative B out? What happens when you take a negative B out? You get a positive X, right?
You're able to just change
And a minus A, because the negative is going to change both those signs.
So you have to change.
And then right here, of course you do. If you take a negative out of something, what must happen to the signs? They
It's
have
got
to change.
it's got to change.
Because when you bring the negative back in, they'll change, right?
And that just
When you
happens.
divide by a negative, the sign changes. We know this.
Or we can put AB minus BX.
Sure, yeah, sure. But what I really want to show you is it's okay to make a mistake. Because you learn from the mistake. You go, okay, those are the same. They're offset by a sign. So I should not have taken a negative out because it made my signs wrong. So I want to show you an example where it's definitely okay to make a mistake. Because the cool thing about these problems is the mistake tells you what the mistake was. It's kind of silly. Don't take a negative out. Then the X will stay negative. The A will stay positive. These are the same now. They're both A minus X. So what can come out?
A minus X.
A minus X. What's left?
X plus B.
X plus B. So that's what I was saying earlier. Doing this first piece helps you with the second piece.
And then if you FOIL that, it goes back to the first.
If you multiply it out, it's got to be that. That's a way to check. Right? Okay. So it's fine to make a mistake. Just don't, what I see all the time though is so this is done, right? So here's a mistake I see all the time. Somebody will do it x, a minus x, and they'll take the negative b out and they'll get x minus a. And then they'll slap everything and say, okay, x minus b, a minus x minus a. Just throw it all in there.
Yeah.
There you go, I got everything covered, I should be fine. There's nothing from this step to this step mathematically. This is just a prayer, right? Just throw in a Hail Mary. That's all I got, let me throw it all out.
Oh, please God, make it work.
There's nothing, I can't go from this step further because there's nothing common to these two. Nothing.
So you're done.
Well, I'm not done, I go back and say, oh, I made a mistake. Like we just said. So instead of taking the negative b out, it goes plus b out. Now these are the same. And I am allowed to go to the next step. Cool. Just the one thing with grouping is, and don't look at it like an evil thing, look at it as a thank God thing. This guy tells you what this guy should be. That's nice. People look at it like it's a bad thing, but it's a great thing.
Amazing.
So let me see. And they really don't get, a lot uglier necessarily. Look at this one. This is 46. Let's do one that's a little more straightforward.
The same section?
Same section.
Okay, right.
So if I group, what can come out of those first two?
9x squared.
Beautiful.
Okay, this is gonna leave you with the, x.
So I had 3 x's, took 2, I got 1 left. 18 divided by 9 is 2. Took both those x squares. I mean,
Right,
both those x's.
okay.
Now, what's true about this term here? Everything's positive. So what do I want to take out of here?
You're gonna make everything.
What do I want to take out of here?
The negative
Minus
4.
Negative 4.
Negative.
To make them both positive. To match it up with this guy. So if I take a negative 4 out of here,
If x,
this negative x becomes positive.
X plus.
Negative 8 becomes plus 2.
2.
There you go. And the biggest mistake on there, I always see somebody take out negative 4 and then they put minus 2 here, and then of course they do the old slam it all together thing, right? But when they don't match up, it's trying to tell you you either took out not enough or you made a sign mistake. It's trying to tell you made a mistake, don't go further, right? And the last step here would be,
9x2 minus 4.
okay,
X
X
plus
plus
4.
2.
some of you guys might realize you can go further on that, but not yet. We haven't officially done it yet.
Yeah.
Yeah.
So the last problem, and I'm sorry to take up time, the last problem, you changed the b, you went negative b to a positive b, but this one you kept it 4 negative.
Because, why? Because when I take a negative 4 out, these are the same.
Right, you're just switching that around to meet the needs of the first bracket.
Exactly, because what tells me I can do the last step? If these are the same. So if you did take a positive 4 out, you'd be left with a negative x minus 2. They're not the same. Oh, okay, I should have taken the negative out also. So it's just telling you what to do, what it should look like. Yeah.
So pretty much, once you get the first set, before you can put the other number down, you need to just move it over here and then find a way to make it all work.
That's one way to approach this, exactly. You can say, I got this already, how do I make this the same? You can try something, if it doesn't work, go, okay, maybe try taking just a plus out, don't take a negative out. Right, so there is a little bit of trial and error here possibly. Most problems should be sort of like this one. It's very obvious I gotta take that negative out. They're both negative, I should take a negative out, right? Only a couple problems gotta be like this one, which is why I wanted to do it, where you try something that doesn't work, so you try something else. That's how a lot of math actually is. So you guys think maybe that every math problem you should just be able to get to the answer directly. Hell no. That didn't work. All right, let me try something else. Right? That's fine. There's nothing wrong with that as long as you kind of have a clue as to which way you should try to go. Okay, so for right now, that's enough. Some of you guys, like I said, might know that goes further, but for right now, we stop there. Is that what you're going to say? We haven't gotten to that section yet, right?
Difference of squares.
Beautiful. 3x plus 2, 3x minus 2, that's light. Cool. If you do that too early, I'm happy with that, that's fine. If you don't know that, it's fine, you can stop right there. So, I'm going to try to do, I think I'm going to try to do section 5.5, and I'm just going to have to let go of my squares and cubes until after this test. It's too bad for me, but I'll deal with it. Because this next one is going to definitely take the rest of the time. In fact, let me kind of stop for a second and refer you back to this. And the reason I like this is because it's based on the number of terms. So you guys, and I can relate to this, you're like, oh, there's so many different freaking factoring methods. And, you know, and I always see people trying to do one method on something that's never going to work that way. The number of terms tells you what to try. That kicks ass. You just got to count, this guy's got this many terms, I'll try this. And then you only have to have that method in your head at that time, not all of them jumbled around, right? So I call this the 0 step, because you always try GCF first. Because either it's the only thing you do, or it makes the problem easier to do. If I can take something out of everybody, hell yeah, I'm going to do it, right? So GCF you always try first. 4 or more terms, like we just saw now, is grouping. And I think actually the very last problem we did last time, I think I did this huge monster thing. It was like 3 things. So you can imagine I could have a lot of terms, and I just pair each of them up, and then hope to God something's common in each one and take it out. So I can extend that idea to more and more terms. What we're going to do right now is, what do you do if you have 3 terms? And this is what I call the classic factoring problem. This is what everybody automatically thinks of when I say factoring. And some people think of this when I say algebra. They think of something like this here, x squared plus 8x plus 12.
Is that the master product or something like that?
Yeah, I don't really do that.
I know, but I'm just, that's what comes to mind, because I know a lot of people don't like master product.
Oh, it's not that I don't like it.
Yeah.
Well, actually, I don't know. To me, it's extra confusion. But if you've learned the way where you make this big old X and you do all this weirdness in there, that's great. Do it that way. That's fine, as long as it makes sense to you. And again, every way I show you is not the way you have to do it. In fact, some of the ways I'm going to show you are ways that my students have taught me over the years. Because they show me, oh yeah, somebody even came up, and I'm like, that's cool, I'm going to start teaching that.
Okay.
There's a million different ways to do this, right? So if you have a different way and I see it in your homework, I might go, oh, I like that way, I'm going to start teaching that. Let's first, before we try to do this, and some of you guys probably know exactly how to do this, but hold on to it, a little side note. Where would that have come from is really what we're trying to do here, right? That would have come from something like, this is not the answer, but would it have come from something like x plus 3 times x plus 7?
Yeah, what?
Wouldn't that end up with a trinomial there?
Yeah.
You'd think so.
You would get, what would you get? You get
X squared.
x squared, 7x,
plus
3x
plus
121.
right? So x squared plus 10x plus 21. Notice how the middle term will always be, when the first one is 1, the middle term will always be this plus this.
Yeah.
And the last term, of course, has to be this times this. And that's why we attack this the way we do, because we know the middle term must be the sum of 2 numbers, and the last term must be the product of those 2 numbers. So it's sort of like its own little side problem. What 2 numbers add to 8 and also multiply to be 12?
6, 2.
6 and 2, right? So what 2 numbers multiply to be 12? So you could try, I will try 3 and 4 make 12 when I multiply, but they don't add to be 8. No. 12 and 1 make 13. No. 6 and 2, yay.
6 and 2. 6 times 2 is 12. 6 plus 2 equals 8.
Thank you. So, how do you make x squared? You put
X and X.
x and x. So the whole problem with this kind of problem,